Thank you. Good afternoon, everybody, and thank you for coming to the talk. I'm assuming people are here because it says that there are 36 participants up on the little toolbar. A year into this, I'm still not particularly used to speaking to a blank screen. Well, it's not blank. I can see my slides, but no audience, which is kind of a bummer. But we'll just do the best that we can. Anyway, my name is Matthew Burke. I'm a mobile software developer at Capital One, and I'm going to talk about adding scripting to your application. So before we discuss how to add scripting, we should at least briefly discuss what I mean by scripting and why you might want to do it. For the purposes of today's talk, I'll define scripting as the ability to add logic to an existing released application without needing access to the program's source code. The ability to script an application is often, but not always, provided for end users who may have limited fluency with software development. Now, originally I was going to say without needing to recompile the application, but I think that just shows, I don't know, my biases or my age. That's not actually correct, since it's possible to script an application written in an interpreted language. In fact, a few years ago, I worked on a rather large project at a different company that allowed end users scripting, and the application itself was written in Lua. So it doesn't have to be a compiled language. You can add scripting to any computer language. And while we're on the subject, also, let me briefly address the term scripting language. I want to define the term scripting language using I know it when I see it approach. So a scripting language is a language like JavaScript or Python or Tcl. It pretty much overlaps with what we once referred to as a dynamic language, and essentially means an interpreted language, one without requiring variables to be assigned a data type. Now, the definitions I've given gloss over a few things. Maybe honestly, they gloss over a lot of things, but I think they're good enough for us to be getting on with. So that's what we're going to stick with for today. So why script? Why give users the ability to add logic to your application? Some of the main advantages of allowing scripting include the following. The scripting language may be more expressive or may be a better fit for the problem domain. So for example, you might have an application for graphing mathematical expressions, and you might give the users the ability to write those mathematical expressions in a language more suitable than, say, C or Tcl or Python or more traditional computer languages. On a sort of different tack, the scripting language may provide a simpler mode of expression, or it may be provide an environment which makes it easy to sandbox and thus makes it safer or simpler to provide for your end users. And there are a number of programs that have taken this approach. Adobe Lightroom, which is a program for curating and editing photos, allows the users to extend the application writing small scripts using the programming language Lua. A long time ago, one of my favorite mail handling tools was a program called MH, which essentially provided a bunch of simple applications which you could glue together writing bash scripts. It's useful to consider 5 scenarios when making use of scripting, and probably one of the most obvious ones is configuration. So if we use a scripting language to implement configuration files, that can be quite flexible. And there's systems that do this at a whole range of levels, from simple key value pairs to full-blown configuration files using lots of complicated logic in the configuration itself. And one of the big advantages of using a scripting language for implementing configuration files is the ability to parse the contents of the file without having to write your own language processing code. I'm going to mention as a throwaway line here that some people that if you read some people's blogs or talk to some people about system design, they may mention scriptable configuration as an anti-pattern. I'm not sure that I know I don't believe 100% in that. As I think you're going to hear me say several times throughout this talk, The correct answer, I think, depends. It depends on the circumstances. It depends on the trade-offs you're willing to make. And so I think there are certain circumstances where scriptable configuration is a powerful and useful tool. Another scenario in which adding scripting to an application is useful is prototyping. In particular, scripting gives you a good way of being able to easily prototype UI and UX, user interfaces and user experiences. Either during development or even afterwards, you can use it to facilitate A/B testing. Is this application, is this interface with a blue button better than this interface with a red button? And I'm, I think, dramatically oversimplifying A/B testing, but I'm not really a designer, so indulge me. There are a number of libraries for implementing so-called tweaks functionality. So the ability to somehow pull up some sort of control panel and adjust the parameters of a running application. Typically this is used during development or during testing, although it can be used during in a production application as well. A third scenario in which scripting is useful is tuning. The idea of tuning is used quite extensively in developing games, but it's also used in all sorts of programming and is very similar to prototyping. But the essence is that as you're developing a program, there are a lot of parameters for which it's not really clear in advance what the value of the parameter should be. And again, I think some of the most obvious examples to think of are things like timing of animations and similar sorts of values. And you don't want to have to be going through a whole code, compile, deploy cycle every time you want to try tweaking the value of the duration of an animation. And so scripting allows you to very easily and very rapidly go through this cycle. One particular example, I'm working on a mobile app for conjugation drills for Japanese verbs. And there are different animations that play depending on whether you get the answer right or wrong to the current question. And questions such as how long the animation should play, how vibrant should the colors in the animation be, what's a good font size to use for the different aspects of the user interface. These all require extensive trial and error to find good values. Or maybe I should just find a developer to, a designer to work with. But either way, it gives me a lot more flexible and rapid turnaround time on trying to identify and nail down these parameters if I don't need to go back into Xcode, recompile my application, redeploy it to a phone or to the simulator every time I want to adjust the value. And so in particular, I have a system in place where I can tap on the screen and pull up a dialog that's got a REPL, a read, eval, print loop. So essentially an interface to an interpreter that exposes all of these parameters that I want to adjust in my application. And I can change the values of these and carry on and see whether I like the new values or not. Again, rapidly without having to get out of the flow of what it is that I'm doing. Debugging is the fourth scenario I want to briefly talk about. In debugging, we want to expose the internal state of an application while it's running. And every IDE I can think of provides a debugger, and they all, or at least almost all, give you the ability to write scripts in some language that can run at different trigger points, usually a breakpoint or similar. And the final scenario I want to mention is extensibility. So here we're providing the end user the ability to add logic to the application. I already mentioned the example of the application that graphed mathematical functions that were supplied by the user. Another example, a few years back, I wrote an application that allowed you to rearrange the icons on a plugged-in iPhone. I'll mention before I forget that the app is currently way out of date, and I'm slowly working on trying to get it back into a running state. But when it worked, it was a lot of fun. What it did is you hooked up your iPhone using plugged it into USB. It sucked down information about all the applications that you had on your iPhone and how they're arranged across the various screens on Springboard. And then it would let you rearrange them and then save that new configuration back to the phone. And the way it did it is it allowed the user to supply a sorting function. So the application had an embedded Lua interpreter, and the main application, which was written in C, would expose all the information about the icons and the applications on the iPhone to the Lua environment as a collection. And then the user would supply a function, a sorting function, that could make use of any or all of this information to decide which application should sort before the other application. And these ranged from, you could very easily do a sort of mundane sort all the apps on my phone by alphabetically by the name of the application, to more exotic forms of sort. So for example, sort them all by the predominant color in the app's icon. I'm not sure that that's particularly useful, but that's certainly something that you could do. And that's a great example of scripting an application, giving the user the ability to take the information and use it in unforeseen and unpre-planned fashion. Now, there's a lot of overlap between these scenarios, and rather than trying to focus on clearly delineating between them, let's instead concentrate on what they have in common. In all these scenarios, we can refer to the host language, so the language in which the core application is written. And then we can talk about the hosted language, the language in which the scripts are written. And both of these languages have an environment or a context, by which I mean the data that's manipulable by code in that language. And so regardless of the scenario, the key point we need to, the key feature we need to be able to implement using a scripting language is we need to be able to exchange information between the host environment and the hosted environment. Now, at this point, I want to take a brief digression to talk about an architectural concern. Particularly if we have the freedom to architect our system from scratch, there's an interesting question of which language is in the driver's seat. If you talk to a number of developers who develop scripting applications, many of them are going to advocate that rather than writing the program in, say, a language like C and then adding a scripting engine to that, you want to flip it around and instead write the bulk of the application in the scripting language, Python or Lua or Tickle or Guile or whatever, and then provide little bits of low-level functionality in a language like C or Rust, and use the scripting language to glue them together. Okay, so an example of this is illustrated here by this diagram. Several years ago, I bought a couple of Blink Ones from a company called ThingM. So they plug into the USB slot on a computer, and they're just LED lights, multicolored LED lights that you can control. And you can control them either with a control panel application that came with the Blinks, or they also provide an API, and you could write your own programs to manipulate them however you so chose. And their APIs bindings to a number of different languages. I wrote a binding to Lua, and if we have time at the end of the talk, we'll look at the code a little bit. And basically what it does is there's some small amount of C code which makes use of this API to manipulate the blinks, and then I can write whatever functionality I want in Lua, making use of that binding library. Okay, and I've written several different Lua applications that let you do various things with these blinks, such as the not very original flash out Morse code to more interesting applications. So what's the better approach? Which language do you let drive the system? And it depends. I mentioned that if you're writing the system from scratch, then a number of people would argue that you want to write the bulk of the application in the scripting language, or what we often call it the scripting language. But very often we don't have the freedom or the luxury of writing the application from scratch. Very often we're in the case of taking an existing application and needing to implement functionality. So there are a lot of trade-offs involved. But the interesting thing is that I would argue that regardless as to which direction you're going, which language you're letting drive the system as a whole, you still have that same core problem of how do you get information from one environment, from one context to the other? How do you manipulate data in one context from the other context? Okay, one other thing that I want to mention real quickly is we really ought to talk about error handling, and we really ought to talk about security. And both of these things, as many other people have said, are things that you really need to consider from the beginning, not bolted on at the end. And with that in mind, I'm going to do what almost everybody does, and I'm going to now ignore them because we have limited time, and I'd like to get to some interesting code, and I'd like the code to be understandable without a lot of background and without a lot of in-depth knowledge. And so I'm going to leave most of the security and most of the error handling out. But keep in mind that it is an important consideration. And whenever you're evaluating what language you should use for your scripting application, you should certainly upfront give some thought as to how easy or complicated the language makes adding security features, handling errors. All right, so with preliminaries of what scripting is and why we should script, the next question that we really need to address, and I'm going to blow through this real quickly, is what language should we use? Well, you can guess from my previous remarks that I don't think there is one right answer. It's not what language should we use. We could talk a little bit about what language can I use. What are the characteristics we need in a scripting language? Well, it should be dead simple to get the information from the host context to the hosted context. It should cleanly express the essence of the problem domain. If we think back to the function plotter example I mentioned earlier, ideally what we want is a language that allows you to easily express complicated mathematical expressions that you can then graph. If writing the mathematical formula to be graphed requires a lot of effort, requires convoluted syntax, then your system's not going to be successful. And as I mentioned just a minute ago, we want a language that allows for security. Ideally, we'd like a language that allows some amount of easily implemented sandboxing, although you should keep in mind that sandboxing is never going to be ideal. And so again, you've got a risk trade-off. Who are the users? How likely is it that they are going to be malicious, that they are going to be error prone? What's your risk tolerance? There are lots of important questions there. And again, I'm going to fluff over them and not go into them in any detail. Real quickly, here are some languages that we could use for doing scripting. Tickle. I'm not sure how many of you out there are familiar with Tickle. Tickle is a language that I like a lot. Roughly 20 years ago, I used it quite a bit, developing interactive websites using AOL Server. I've got a question just popped up. I'll get to it in just one second. Python is an obvious choice. It's an immensely powerful language in its own right. It's also used as a scripting language in various applications. The code here is an example from Blender, a popular open source 3D tool. Guile. Guile is GNU's ubiquitous intelligent language for extensions, and basically it's a dialect scheme, so a dialect of Lisp, if you will. And yes, I know there's a big difference between Lisp and Scheme, but I told you I'm glossing over and hand waving a lot of details. The example here is user supplied code for creating a report in a program called GNU Cache. And then finally, we're going to talk about Lua in detail for the rest of this talk. The question that popped up in Q&A is, I've heard you mention the Lua language a lot in your talk, and from my understanding, Lua is usually associated with the BSDs. What do you like about Lua compared to other scripting languages like Perl and Python? So a couple things. I suppose that's true that Lua is often associated with BSDs, with various flavors of Unix, Linux, those sorts of operating systems. However, Lua is actually available on almost every system that you can think of. I know a number of people who use Lua in Windows environments. I've used Lua myself in a number of embedded environments, like with the ESP80. Oh, that's the problem. I'm blanking on the number, but the ESP, not the ESP32s, which are the newer ones, but the older system on a chips. They have a Lua system that you can use for coding them. There are a number of other embedded systems that have really nice Lua systems embedded in them. There was, for example, for a while, there was a series of LED screens that had a built-in Lua interpreter that you could use for doing interesting display. What do I like about them compared to languages like Perl and Python? One is the small size. I think even though we're now at the point where, for example, IoT devices have memory measured in megabytes, I think still having small size often of the interpreter often can be very useful. Probably the main thing I like about Lua, and as we'll see in just a few minutes, I mentioned that one of the things you want is a very simple way, a very powerful but simple way of getting information back and forth between the host language and the hosted language, and I think Lua nails that down to a T. In fact, one of the first things that drew me to Lua was back before the turn of the century. I was developing Palm Pilot applications, and there was a version of Lua that was available on the Palm Pilot called Plua. And Lua made it very easy. Plua made it very easy to interact with the Palm Pilot OS and to extend the functionality. And ever since then, it's been one of my go-to languages. The code up here is code that works with Mod Lua, which is one of the modules that's distributed with the Apache web server. I've used Lua on iOS. I've used Lua in Android. I mentioned Palm Pilot and quite a range of platforms. I think at this point, I'm going to skip over these couple of slides about an introduction to Lua. There are some syntactic differences and some others, some design choices that a lot of people are up in arms about, one-based indexing versus zero-based indexing being the chief one. But Lua, by and large, looks a lot like most of the other programming languages that you're familiar with. So I'm going to skip over these couple of slides. And as we're talking about, as we're looking at actual code, integration code, we may come back and hit some points about Lua if it turns out to be necessary. So let's talk about an example. Let's take a look at an example of scripting an application. And so for this example, I want a simple program. I'm going to show you a program in C, and I'm going to show you how to embed Lua into it and how to get that interaction between the two different environments. And so I want a program, a C program, that provides the minimal amount of distraction to get something that's just begging to be scripted. So of course, here it is, hello world. Okay. At this point, it occurs to me that I was gonna run a poll earlier on, and one of the questions was just a general survey of roughly how familiar all of y'all are with C programming, but naturally, I didn't remember to do that, so I'm just going to braze on. This is basically pretty simple. The pound include line at the top is how in C we bring in declarations. One of the things about C is that typically declarations and implementations are separated. So declaration is declaring the names of variables, of functions, and so forth, and what their types are, and then the implementation is of course the implementation. So here we're saying we're going to make use of the standard IO library, and we're not doing a whole lot. We're going to print out hello world. So how are we going to script this? Before I show you that, let's just say a few, let's just go over a couple other points about C real quickly. Okay, so C is compiled language, and it's a language that's statically typed. So if we look back here, for example, main is the function, it's the entry point to our application, and it's of type int. It returns an integer, which you don't see here, but we'll ignore that for now. So it's a statically typed language. Handling of memory is manually done. You use a function called malloc to allocate memory, and then you have to remember to free it. And if you don't remember to free it, really bad things happen, which is a big motivator for why we have a whole bunch of other languages that we program in. C lets you make use of pointers. And despite the nasty, evil things you've heard about pointers, which basically are ways of being able to manipulate and access different spots in memory, pretty much every language lets you use pointers. It's just that some of them wrap it up and hide it behind the curtain a little bit. In particular, there are two things to keep an eye out for as we look at C code. If you're not familiar with C, the asterisk. Anytime you see an asterisk or ampersand, you know you're dealing with pointers. The asterisk is dereferencing. So we're going to take a pointer, in other words, a variable that doesn't have data in it, but it has the location of data. And the asterisk says, take that location, go out and get me the data. The ampersand kind of works the other way around. The ampersand takes a variable and grabs its address. And then we can use that to take regular variables and turn them into pointers. And as I mentioned just a minute ago, one of the big things about C is there's oftentimes this separation between the declarations. So you'll get, for example, these .h, these header files that declare functions and variables and so forth, and then their implementation in the .c files. So the first step in scripting Hello World is we need to embed a Lua interpreter. And for the most part, subject to limitations of screen size, what I'm doing in these next slides is code that you've already seen is going to be in white, and new code is going to be highlighted in green. And so to embed a Lua interpreter into your program doesn't require a lot of work. We have two header files that we need to include, and we need to create a Lua interpreter. And we do that on this line here with the Lua-L new state function. One thing to keep in mind about the Lua API, any function that's prefixed with Lua underscore is sort of a core API function. And any function prefixed with Lua-L underscore is in this auxiliary library. They're sort of convenience functions. So we could get by without them, but it's going to make life a lot more complicated. There's more code that you have to write if you don't use these helper functions. So to embed a Lua interpreter, all we really need to do is we need to create a new state and store it in a variable. So that's what this capital L is. The Lua, it's a pointer to a Lua state. It is possible to embed several Lua states in an application. If you have a multi-threaded application, if you want to make use of multiple cores, that can be useful to do. I'm not going to talk about it here. And then in the next line, what I've done is I've moved the responsibility of printing Hello World out of the C realm and into the Lua realm. So we make use of this helper function Lua-L doString, which does the obvious thing. It takes a string, which should be valid Lua code, and executes it in the state, in the interpreter. And if we run this program, we get this output here on this slide. So that's probably not what we were expecting. So I said that by and large, I'm not going to really talk about error handling or any of that, but I do want to briefly mention it here. So let's see if we can sort of figure out why we didn't get any output. So I'm going to add one more library, the standard lib. This is the C standard lib. I need it to be able to get exit, which you see down at the bottom. And I'm going to use that. I'm going to execute that doString command, and I'm going to take the return value, which is an integer. I'm going to capture that in a variable. I'm going to check to see if it's equal to the constant Lua OK. If it isn't, that means an error occurred. I'll print out an error message and I'll exit the program. In most Unixes, and I'm not sure about Windows and other operating systems, the convention is that if a program returns 0, it's run successfully. If it returns a non-zero value, that signals an error. So I'm going to return 1. Now, we need a little bit more to understand what's going on. Let's pretend that we've done a little bit more debugging and triaging. The problem is that print hello world will only work if the print function is defined in Lua. The core Lua provides a real minimal set of functions. And one of the functions it does not provide is print. And if we want the print function, the easiest way to do that is to take our Lua state L and inject the Lua standard library functions into it. And that's what I'm doing here with this green code. The key point here, though, is that if we don't need all the standard library, we don't necessarily have to include it in our Lua state. I don't show you, but there are 5 or 6 different sub-libraries in the standard library, and we can include just the ones that we want. We can also separately create our own libraries and include them into the state as well. If we include the standard library and run the code again, we get what we expect. We get hello world. Now let's take this a second step, because that's not a particularly compelling use of scripting. So here what I'm going to do is 2 things. First of all, the bottom line, the printf, I've moved hello world back out of Lua land and back into C land where it was originally. So the C program is responsible for printing hello world. But the other thing that I've added here is I'm going to read in and parse a configuration file. So this configuration file is going to be a file. Here I've hard-coded the name hello.cfg. It's some valid Lua program. And so what I'm doing is I pass in the Lua state to the configure function, which is at the top here. I'm ignoring error handling and so forth. I'm running this helper. I'm invoking this helper function do file, which takes the name file, reads it in, parses it, and runs it. And whatever variable and function definitions occur in that Lua script are going to be permanently embedded into the Lua state L. And so I can make use of them later on in the C program. But notice that I'm not really, I still haven't yet achieved what I said we need. I'm not taking any data from Lua land and making use of it in C or vice versa. So we're not really there yet. Okay. And so to get that interaction between the 2 environments needs a little bit more work. This is not necessarily the best way of doing this, but it is the easiest. So I'm going to create an array of 256 characters called name. I'm including the string library because later on I'm going to need a function called strcopy, which copies a string from one variable to another. And I'm going to call this function getName. And the result of the function after it completes is that the name variable is going to have some data in it. And down here at the end, I'm going to use that data to print out my salutation. So now I can use the config file, and I don't just have to say hello world. I can say hello to whoever I've configured via the config file. Let's take a look at the getName function. Okay, here it is. Again, no real error handling or checking. Let's look at the key pieces. So here I'm making use of the Lua API. Notice this is the core API. It's not Lua L, it's just Lua to get global. So I'm assuming that the configuration file is going to set some global variable called name. I'm going to grab that value, and I'm going to then use the toString function to pull that out of Lua land and stick it into n, which is a function in the C environment. And give me just 1 second. I need to move this Q&A window out of the way, which is tricky because my cursor is invisible for some reason. All right, I'm giving up on that. So let's talk just a little bit about how this Lua two-string functions. And to make it clear what's going on here with the two-string function, I need to talk a little bit about how data is passed back and forth between Lua and C. When C code invokes a Lua function, it gets a stack. And this works the other way as well. If Lua invokes a C function, it gets a stack of data. And all the information that's transferred from one context to the other is passed on this stack. When the C function returns, or when the Lua function returns and wants to communicate information back to the other context, it puts that information on the stack as well. I really ought to call this a stack-ish data structure, because you can actually easily access any item on the stack. Whereas traditionally with a stack, we limit ourselves to only being able to access items at the top. But by and large, this behaves like a stack in that we're going to push things onto it and we're going to be able to pop things off of it. The indexes that we use, so for example, you see here Lua two-string L, because we need to pass the Lua state to every Lua function, and then -1, that's the stack index. Stack indices, positive stack indices, start with 1 at the bottom of the stack and go all the way up to the top of the stack. The negative indices work the other way around. So -1 is the item on the stack. And so what we're saying here is, I want to grab the item from the top of the stack, and I'm assuming that it's a string. Ideally, I would have already checked to make sure that it legitimately is a string and signal an error if not, but I'm cutting corners. So we're grabbing this string that's on the top of the stack, we're copying it into this variable n, and then we're going to use the string copy. Remember, that's the C standard function for copying strings from one variable to another. We're going to copy it out of n and into name, which I passed in. Now, if I was doing this for real, I wouldn't do this two-step process, but I thought it would make things a little bit clearer if I had the two different lines here. So as I mentioned, we're taking the data out of n and we're putting it into name. The one thing you have to be careful of is again, handling memory properly. Lua is a garbage collected language. And so you need to make sure that if you're referencing things like strings, that they don't get collected out from under you. And the API provides guarantees about when garbage collection will happen. And I'm not going to get into them because we don't have time. Just to give you a little bit of taste, here's something with a little bit more error handling included into it. So this is approaching reasonable code. So I'm going to get the global name. We've already seen that. And that get global function returns the type of data in the name variable. I'm going to check that type to make sure it's a string. And if it is, I'll make use of it. If it isn't, I'm going to print an error message and exit. And I could be even more safe and secure here. I can handle things better. If the variable isn't defined at all, if my configuration file does not define the name variable, then what the name type is going to be is going to indicate that name is nil. And so I'll use a default value here. I'll fall back on saying hello world. So the point here, the main point being that the Lua API has quite a bit of machinery available to you for being able to properly detect and handle error situations, even if I'm continuing to cut corners. Okay, so here's what the hello configuration file might look like. In Lua, comments are prefixed by 2 dashes. So I just have a comment here indicating the name of the file, and I'm setting name equal to Sophia. And if we were to run this program with this config file, the output we'd get is hello, Sophia. Now let's take this one more step of complication. And I think since I have the time for it, let me zip back in my slides and let's just take a look real quickly at this slide here. Another aspect I really like about Lua, and one of the key aspects of Lua, is that Lua has one core data structuring mechanism, and it's called a table. And essentially, a table is a combination of an array and a dictionary. And so, for example, here you see I'm defining a table called T, and I'm making use of both that functionality. I'm assigning value 1 and value 2 to two keys. And the 3, 4, 10 essentially are going into, you could think of there being a sort of array portion of this table. So at index 1, I'm going to store the value 3. At index 2, I'm going to store the value 4. And at index 10, I'm going to store the value, I'm sorry, at index 3, I'm going to store the value 10. So I really like that about Lua, the fact that there's this one key data structuring mechanism, and it's very flexible and very powerful, and the implementation is very elegant. And we can use that along with some syntactic sugar, which I'm not going to go into, to get some very expressive Lua code, particularly if we're using Lua for configurations. And so very often, if you use Lua to do some sort of scripting configuration, you're going to see these table data structures floating around. And so if we now switch back to the C code for this more complicated example, what we're going to do is, rather than getting data out of global variables, we're going to get data out of tables. So here I'm getting more information out of the Lua world. I'm going to get a count, and I'm also going to get a salutation, whether you say hello or goodbye or greetings or whatnot. All that stuff is going to be configured in Lua. And you see down below, I'm going to make use of that count. Is going to control how many times I repeat saying hello. And I'm going to grab the name, and I'm going to grab the salutation. So this greeting details, we pass in a pointer for name. Notice on the slide below here, I've got 2 character buffers, one for name and salutation. I'm going to pass them both in, and then I'm going to make use of that ampersand to turn the count variable into a pointer. And here's the crux. I'm going to, for simplicity's sake, I'm going to assume my table is, sorry, I get up here the table, I'm going to assume it's in a global variable called greeting. And then I need to get items out of that table. And so it works pretty much the same way. I'm going to push onto the stack the index, the key that I want the data from. I'm going to then use this get table function, which grabs data out of the table that's on the stack. And the index here, -2, is telling me what stack position is the table is located in. So it expects a table at that position, it expects a key at the top of the stack, and it returns the data onto the stack. And then with the string copy, that 2-step process that I did before, I'm combining it into one line. I'm going to grab the string at the top of the stack. I'm going to copy it into the C variable name. That doesn't remove that data from the top of the stack. And so this next line, Lua set top, will do so. So it leaves the table on the stack and nothing else. So I can do the same thing for salutation. And then I can do down here at the bottom, I can do similar code to get the count. And if we look at the config file, here's an alternate syntax for creating a table and specifying values in it. So I've created this greeting table. I specified the name. I've specified the salutation. Ohio is informal for good morning in Japanese. And I'm going to repeat it 3 times. So I'm going to print out Ohio Yoshi 3 times based on this configuration. But remember, this is a Lua program. And so I could do something more complicated if I wanted to. So now the value of count is going to be a random number. from 1 to 10.
Sumimasen, Matthew.
I know I'm almost out of time. Very much out
Okay.
of time. Thank you. Thank you.
You're welcome.
So this gives you a taste of scripting in Lua. And so there's a lot more that we could talk about in terms of Lua functionality and how to access it from the API. And certainly feel free to reach out to me later if you have questions, and I'd be interested I'd be more than happy to discuss in more detail. But there are two important things here that I wanted to go over. And so one was I wanted to give you some detailed example of doing scripting with a particular language. In the first half of the talk, what I wanted to do is I wanted to give you ideas of what scripting is all about, why you wanted to script. And so hopefully I've covered who, what, where, why, and how. And I hope that the last 45 minutes has been useful and interesting. As I said, since we're out of time, please feel free to contact me. I know that they're going to make the recording and the slide decks available, so you'll have my contact information. And I thank you very much for your time, and I hope you enjoyed Open Source 101.